Hey everybody, so welcome back to another dev video. Now this is technically part 3 of the double slot furnace we were working on. I did actually record what can be considered an episode for part 3. After all, we've actually gone and almost completed it already at that point. However, that episode had been clipped apart into 7 different sections because I continuously got interrupted while I was recording it, and for the most part I just kind of scrapped it. So rather than going over that, because it wasn't really that much, it was mostly me just toying with things, I'm just going to go over what has been done. At least I'm going to go over what I think has been done. It's been, I think, 2 weeks, almost a week and a half, somewhere around there, since we did the previous 2 episodes where we did the design and implementation of the furnace, and this is the rendering of the furnace. Now, what we are doing is we are using what is called an ISBR, so an I Special Block Render Handler. This is something that only exists in 1.7 and before. I don't even think it existed even that far before. 1.8 it was removed and replaced with the baked model system. The baked model system is not much different. It is different, but it's not extraordinarily different. Whenever I figure out how to do 3D models on that, I'll do an updated tutorial of where I'll explain how to do the same exact functionality in the newer code. But anyways, what this code does is allows us to start first to change the render code of the inventory block, and also to change the world render block. Now, the world render block is only ever re-rendered when the chunk re-renders. So this is run once, which is a reason why I like to use these, is they do not impact frame rate. So if we go in here, even with all the conveyor belts over here, my frame rate still maintains a 60. Usually if I turn VSync off, my frame rate sometimes will go all the way up to 180. So I do have a better computer than most people have. But it does give a notation that these guys don't really matter. Probably do some testing later. I might go pull out like the most shittiest laptop I own and actually run it through to test these guys. So to walk through these, what I did in the previous thing, which I know you guys are not going to know what I did, but we set up boxes to render. So first we told it to render all faces, this way we don't have any faces turning off automatically. Normally what you'll do is you'll tell it that it's not going to render as a normal block, and you'll tell it it's not opaque, and this should turn off automatically. I was having issues, so I told it, hey, I want you to render all faces no matter what happens. We are having some lighting problems still, which I gotta get around. We get the direction, we're just taking the lazy approach, and we're pulling it directly from the metadata, which works because our metadata is our rotation. We are then rendering the base. So the base is this bottom piece down there, which we are currently using the double slab render to render, which looks really nice. It actually looks pretty nice. We are then rendering 4 walls, which we can actually see. So these walls right here on the sides, those are the walls we're rendering. Now, because an ISBR does not allow for rotation, we effectively have to build up 4 different variations of the model. Because we're also not using my JSON model system because it does not support doing models like this. It does support doing Techni type models, but I don't have code to set up the render Techni models ISBRs are at the moment. You can actually take a Techni model and you can render it as this, even though I think there is some complexities involved in the process. But when you're doing the 4 walls, so we want to get rid of the front face, we have to essentially go, okay, if we're not rendering that side, so if we're not north, then we render the side. But if we are north, then we don't render that side. So this side would not render, this side would not render depending on rotation. That way it gives us this little pocket, but then we don't have to do any more complicated code. We are then rendering the cap and everything else. Now the previous version also had pillars and a few other different things and variations to make it work, it look nice, and the client decided he didn't like the way it looked. And let me go ahead and drag this, if I can drag my, can I drag my OBS window? No? I'm having all kinds of technical difficulties with my computer these last couple of days. So what I'm trying to do is drag this window over, and I just figured out I can only grab the purple bar if I want to drag it. That might be intentional. So he decided he wanted to look like this because because what he wants is he wants this. And I sent him as the previous version, which was this. It had some pillars in the back, it had a bottom, and he said he didn't really like it, didn't look really well. Although he got kind of confused and he thought this was all one block, and it was my mistake on trying to inform him of what it looked like and everything else. So we kind of talked back and forth, and he decided he wanted it to look different. So now we're on this version, and right before I go ahead and finish this, I want to include you guys in the process. So if you want to do your own ISBRs in 1.7, you can do it, although it's kind of obsolete. Anyways, we're going to implement the smokestack here. Right now I'm just going to do a solid block just to get the shape down, and then we'll come back through and we'll put 4 walls on this. That way it's got some volume to it that isn't solid. So we want to do our starting point to be the top of our previous point. This is the top of our cap point, which is the top of our furnace. And then we want to take this pretty much to the top of the block, which is 2. Now, because of the way we're rendering this, this is actually being rendered outside the normal block. You don't want to do this. Usually when you make your ISBRs, you almost always want them to stay within the 1 cube block. I'm cheating. I'm taking it outside the 1 cube block. And all we have to do is do an update, and that did not render properly. We weren't paying attention, and we didn't do the size for it. So we want to sit here and we want to scale the size. We also want to change this to 0.2. Change this to 0.4. This goes to the top of the block, but then we want this guy to go to 0.6. We'll do a small little stack real quick. I'll increase the width as we go. So this it works. This is your minimum X, minimum Y, minimum Z, max X, max Y, max Z. It also helps when you're working on these to sometimes indent these, so that way it's less confusing. I did that up here. It also really helps to name your objects as you're working on them. One that gets rid of the IntelliJ's little dumb thing, which it tries to tell you what the variables are. I think I might come through with a plugin and see if I can turn off if the thing starts with a P underscore. Just don't display it because there's no point, because the field's unreadable. Or come through and come up with some ingenious way to auto translate these for me. So let's see. Go ahead and click this, and let me make sure I reloaded. I use Alt-R to reload. The default hotkey for reload does not exist in IntelliJ as far as I understand. You can set the hotkeys up in the config settings. Yeah, that's way too small. So we want that to definitely be nice and beefy. So what I'm going to say is we take this to 25% off every edge. So 25, 25, then these would be 75. You guys could do math to do this automatically. So if you decide, like here, actually let's do this. Final, we'll call this stack edge. And of course we want this to be a double. What are we using up here? We're using flits. It is important to kind of make sure you get the data type right, or you'll have to cast it. 0.25F. And we'll put the stack edge down here. So one, this will get rid of that annoyance we have going on. And what we can do is we can do 1 minus stack edge down here. So this will auto update for us. So we only have one variable to edit our entire setup. We come back in here. There we go. We got a nice beefy stack edge. Now, I don't know if we want to keep that as... Well, you know what? I kind of like this slab texture, and what we'll decide is... we go update that. But as I said, it only updates when the chunk updates. So there's a chunk border probably between here and there. So like when I place something here, it only updates this. It'll also do on neighbor block object. So if I click this spot right there, it'll update both that block and that block. It will not trigger these two unless the chunk re-renders, but of course the chunk will probably re-render. So there we go. We got a furnace thing. Doesn't look that bad. Now we would want to mingle the textures around to give this more depth and everything. So let's go ahead and change our icon. Now we are rendering via a render method, I believe. Which is, yeah, it's calling this down here, which is setting the override texture and doing a standard render. So we're using an override texture system to render our block. So I want to render a cobblestone here. And I'm going to change the sidewalls to cobblestone as well. Oh, we accidentally clicked that. Trying to use this little laptop mouse. My previous mouse kind of stopped working properly, and I took it apart to clean it. I put it back together, and it worked exactly the same as it worked before I started cleaning it. So I thought that when I was cleaning it out, it would start working better, and that was an illusion. Now, hold on, I need to close that completely. So, needless to say, I end up having to throw it in the junk pile. I'll probably come back through and try to fix it again. I think what's wrong with it is one of the switches has kind of gone out on it, which happens with electronics. But I see how that gives it more character. So you get a little bit more depth to it. It looks nicer. What we would actually want to do is come through here and actually make our own textures for this down the road. But this is a good start. This gets the client roughly what he's looking for. And I can give him something to play with while I finish up the stuff. Because one of the big things, the problem I have when I'm working with these clients, is they can get really impatient when it comes to working on stuff, and I always need to tell this to clients, and I kind of forget to do it all the time. It does sometimes take a while to make things, something that looks really simple. So this looks like super basic, looks like something like you can do in a couple hours, which you could do. If you had everything set up and you had everything to go, a couple hours would work really, really well. The unfortunate part is that I have to implement everything. I don't have any code sitting around just to make this stuff. There's nothing around that just I can go copy and paste. So it does end up taking a couple weeks to do. And it takes also a couple weeks for the fact I have to maintain my own mods, so I only spend a couple days out of the week working on freelancing projects right now. And of course clients don't get really happy about this. Although they get ecstatic that when you finally give them something and they're like, oh, it's so pretty and shiny, because you look in Minecraft itself, I get the luck that I do work with a lot of clients that aren't experienced with mods, and this is your vanilla equivalent. It's a block, that's it. So when you see something 3D in Minecraft, especially when I start doing something like this, so especially when I start giving clients actual 3D models that don't look like the standard Minecraft models, and then I turn around and let me get some items here, and we change the code so that way when you put stuff in it, it updates, it renders, and then when you take and put something like food in it and it changes this render even further, that blows a client's mind because you don't see this in any other thing. And we're going to take this exact same thing we did with this, by the way, and we're going to put it on this over here. This is going to take probably a Tile special render, but before we get to that, let's go ahead and finish that, and I'm going to go ahead and break that so that way it's out of the way. So we want to finish the smokestack, so that way we can also do a particle effect to have smoke pop off of this when it's running. And we also want to do some lighting and a few other things. So we're not much longer to get this done. And then what we're going to do in order to render this is we're going to have to do some guesswork, mainly. So you know where our stack edge is. We're going to do final float stack start equals 1.2. Final float stack end equals 2. And we got to put F after to tell it that it's literally a float. That's what that F means. It's literally a float. Because anything else is a double. So there we go. So that'll get our data points at least cleaned up, so that way it's a little easier to read this. And we need to set up some wall thicknesses. And we also need a render. So we're going to have 4 of these. And we need to name them. So we're going to say, okay, this is the north. And we'll go ahead and we'll also put something like that. And then I'm going to put stack start right here. Actually, we're going to move all of our variables to the top. And the reason we're going to do that is so I can recycle them if I need to. And it also is really nice when you're doing stuff as well to put all your variables to the top, so when somebody opens up your method, they go, oh, this is all the variables this uses. And there's a lot of variables, by the way, too. We may actually end up, when we're finally done, we'll take all of these and we'll put them up at the top of the class. That way we're not reinstantiating. There's like no chance of reinstantiation. They're constants. By default, they should be constants anyways, but when you're programming, it's better to play it safe than sorry sometimes. But the reason why I did that as well is I can take and I can put stack start right here. And that works. And then is there another thing I can do? I can put wall end right there. If you can use variables, it works really, really well, because if you come down through here and you go, okay, I want wall end to be 1 pixel taller, it'll push this up by 1 pixel or push this up by 1 pixel. And it'll basically move all of your stuff automatically. So it's good to kind of derive all of your data off the previous variable, so that way when stuff moves, it moves with it automatically. That really only works for ISBRs, by the way, because if you do normal models, that's not how that works unless you're using the same vertice data, which is a thing you can do, by the way. Anyway, so we get these, and I'm trying to think of like exactly how to do this. And I don't want to end up doing the same thing I did with all of the variables up here, because we got a ton of variables to make this stuff work. But that's kind of what it feels like I'm going to end up having to do now. So that would be the quickest way to make this function. But the easy way is not the way I always like to work with things. So we want the north wall is going to change in the Z area. So we got the stack edge. So you want to go stack edge plus some kind of thickness value. So we go final float, float stack thickness. And we're going to say it's 0.01F thick. So we're going to go and do that. So there'll be plus stack thickness. And then this one we're just going to do the south one directly below it because the south and north are going to be almost identical. And then I'm going to comment out the other two. That way we can test the rendering of just these two. And this one's going to be... So our starting point on the Z-axis is not going to be stack edge. Our endpoint is still going to be 1 minus stack edge, but it's going to be 1 minus stack edge minus stack thickness is going to be our starting point. So go ahead and reload. And there we go. That looks pretty good. And let's go ahead and update the other ones. By the way, so where I was talking about that there's no rotation for this. So when you build an object, you have to kind of determine what your rotation is via if methods. You cannot rotate parts in this. There's no way to do that. It won't let you. The only way you can actually rotate a part is instead of calling render blocks, you could do your own UVs, and then you could move the UVs. So you can say instead of my UV starting at 0, 0 and then going to 1, 1, you can say it starts at 0.5 and then goes to 1, 2. And that will give you a diagonal. Anyways, these guys down here are going to be roughly the same, except we're just going to be doing the X direction. And to be honest, I don't need to make sure these are perfectly correct. I'm just going to call them east and west, even if I end up accidentally inverting them. It doesn't really matter. As long as one of them starts on the X direction and ends on the X direction, then that's all that matters. So stack edge plus stack thickness. And the other one is going to be 1 minus stack edge minus thickness. And we'll go ahead and move this up to the top. And let me go ahead and also put a divider line here so I know that everything under this is part of the stack edge, or part of the smokestack. Really good idea to kind of do stuff like this because it does make finding stuff easier. I kind of wish that I could do hide tags. I think it's C#. I think it's any of the Visual Studio languages. There's a way you can do a start point and end point, and you can collapse sections. So you know how I can collapse that? Like imagine doing that, but then you can collapse an entire section down here. It's something that you can do in a few other languages. I think it's Basic is where I learned that from, and I learned that many years ago, because I think I was in the 9th grade when I did that. I have been programming for a very long time is a good way to put it. Okay, so we got some Z fighting now because all of our corners overlap. So we are going to want to pick 2 of these and then drop their thickness values. East and west are the best sacrifices. So we want to take, and we want to go plus stack thickness here, and then minus stack thickness. And this would be I think it's the same exact way. I paused for a moment because my brain was trying to figure out what it was doing because this line didn't match up with the line below it. There we go. Nice, good rendering. The block textures even match up well. This is one of the perks of how the block render system works in Minecraft, is that it will use the UVs of the side. So you calculate the side of the block you want to render, and it will match the UV to your side automatically. So it does a lot of UV mapping on its own, and it looks really, really nice. The only downside is you end up with problems like we see with this right here, where the texture is compressed, as it can't figure out how to UV map correctly. If we ever did want to fix that, we'd have to write our own code for this. So I do plan to do this eventually, as I kind of want to render things like this using more static UVs, because we have little glitches like that where that doesn't match that. In order to fix that, what we could do is take and make this where that point starts there, but then the point there goes down to over here somewhere. That way it's no longer a rectangle and it's more of a rhombus. And since I know some people won't understand what rhombus are, and I just realized some of the icons on my computer are glitched out. If I crash while doing this, I blame my computer. But at least I think I'm calling it rhombus correctly. But it'll be something like this, where it'll go down straight like this. I think it's a rhombus. I might be wrong. But either way, it's you wouldn't have like proper angles between these. These would be non-normal symmetrical angles, and for those who are familiar, this would be like that, and then you would have your nice pretty obtuse angles. But that would fix my belts and stuff. We'll do that in a later episode, but I thought I would point that out because you can actually fix this system with doing this over here. Although you can also do this type of stuff in this type of code. This runs a tile entity special render, by the way, which we'll get into next. But yeah, this looks good. So that's pretty good. So I'm gonna go ahead and take a screenshot here real quick so I can feed that off to my client. It's always good to have progress pics. So we're gonna close it because I'm gonna have to set up the tile entity special renders. You can't just make a new object. So we'll go and we make sure this is in the right folder. I do have a gen folder because we do generate things. So this would be tile entity special render dual furnace. Extends tile entity special render. Now I think I can actually get away with rendering the flames in the ISBR, but I'm going to render them in the tile because then we don't have to re-update the chunks. We don't have to re-render the chunk, which will cause more frame rate problems than just making a tezer. So tezers do run decently well. The reason you want to avoid them though is because they run every single frame. So if you're rendering 120 frames, this is updating 120 times. At least I think it is. It may not be updated that quickly. There's some nuances to how the Minecraft render system works, and it does change between versions. Because then you go into like 1.8 plus, and then all this stuff is baked. So we want to first thing first, go make sure our tile is a furnace. Tile dural furnace. Actually, hold on. We can't do that. We have to do tile is an instance of iTile host, and tile.get tile node is an instance of that. And what we'll do is we'll cache our door furnace so we don't have to mess with it, because we are messing with a node system. It's basically what this is. It's the reason why we have to go through such an elaborate way to get access to it, is that there is a tile being created for us that exists in the world that then the node sits inside of, and we do all of our work on the node. The benefit of this is that the node is no longer bound to the world and will run on its own little logic. So it's self-contained, self-running. It means you can also take any of the nodes you make and you can slap them in anything. So you can put them in a simulation program, you can do JUnit testing on them, you can have it hover in the player's inventory, you can have it follow the player, you can have it be part of the player's object, you can have it be part of entities, you can have it be part of a minecart. It can even be attached to a rocket and it would still work. Given the code is not fully set up for that, but that's the premise of the concept. Anyways, we want to render fire. Pretty straightforward, so we're going to do gl11.gl push matrix, I believe. We'll get the code here. So push it onto the stack, pop it back off the stack. What these do, by the way, is you just keep track of what our previous rotations were, so that way when we rotate stuff, we're not screwing with things. gl11.gl translate, if I can type today. And we just want to translate by the coordinates passed in. We're going to center this too. That way we're actually centered on the block. We're only going to center in the X and the Z. We're going to leave the Y alone because we want to render a few things in here. So first thing is we're going to want to render coal. So we're going to render charcoal. And then we're going to render flames. And then let's go hunt down our campfire so I don't have to redo things. Tiling render campfire. So here is the code to render the campfire, and it is some sloppy code in my opinion, but it works. And it looks like we use this code to run it, and we may have to scale this too, so this might be a bit too big, but we're gonna run another GL call here. Tile Render campfire. I'm probably going to abstract that code and I'm going to turn it into some kind of like object called render fire. This had to be modified, by the way, to work. You can't just run block render code inside of OpenGL methods sometimes, because they do a lot of startup and tear down stuff that doesn't work. So I had to copy this, modify it, toy with it, and make it work. It also grabs its icons and everything else. And we want to render cool, but we're going to have to make a model piece for that. I'm trying to think of how to do that. Anyways, we want to translate this guy. So when we come in here, we set the terrain texture. Then we want to pop the guy up probably by 1 block. So we translate up 1 up. And we're going to do the same thing here. So we're going to like start rendering something, stop rendering something. You can also just remember these as start render, stop render. Even though in reality what this does is it pushes your previous rotations onto the stack and then pops them back off the stack. And the stack would be your memory, by the way. Although this is graphics card memory, so it's a little different. Is that how that kind of works? I'm a little confused to how Geo works, so if I'm wrong, you guys can comment in the comments and tell me I'm wrong. I'm okay with that. So we want to translate this guy up to, and then we're just going to render a block here. So I'm going to use render utility dot render cube, and we'll use this method down here. Let me go ahead and look at it. So that'll be a min x in our block. So the block we want to render is blocks.charcoal, or no, blocks.cool, cool block. And then our starting point is going to be, so we don't want this to be a full block in size. So I'm going to say 0.4 in all sides. And because we've already centered this, we don't have to actually tell it where we're going to render it. We just have to be like, hey, this is what its dimensions are. When it comes to the Y level, this needs to actually be 0. And this needs to be 0.2. We don't want that big of a piece of charcoal in there, but we do want it to be sizable enough. So that'll render that cube and it'll show up. We do have to bind this though. And we can have a tile special render and ISP at the same time. As long as our render type is not the standard Minecraft render type, it should work. I think. I think we may have to actually register this separately. Yeah, we're going to have to register separately. The reason I say that is if we try to use the JSON registry system, it doesn't understand how to register tile entity special renders by itself, because you're not supposed to make your own tile entity special renders. What you're supposed to do is you're meant to make a listener, register the listener, then do stuff with the listener. And we have a few other things too. Like we have to tell us if we got fuel. Right now we're going to just set up the render code, and I'll do the if check if Goat has fuel. Yeah, actually we'll go ahead and say we'll go boolean has fuel equals true, and that's my alarm to go feed my cat meds, rather my brother's cat, is cooking. And we'll just go set this up. And how this will work is we'll just put an if statement right here. So go if has fuel or is cooking, because we could have a really weird setting where it has fuel or is cooking. And this would just be is cooking. So we only want the fire to turn on if we're cooking something. And yeah, technically we can also use because what this will end up being is has burn time and has fuel time, or has cook time. So that looks good. And then we just got to come down to the client proxy and we just have to bind this thing right here. And our actual binding will be tile entity wrapper, or tile entity, should be a wrapper for this. It's named incorrectly. It's called tile wrapper. It should be tile entity wrapper. So we'll bind that, and then we need to make sure we're using the right thing here. So we'll be using Tether dual furnace. You see I've manually bound a few other things. These ones are manually bound because they're not nodes, but the node system I'm going to have to work on. What I really should do is I probably should switch over to the listener and use the listener because it'll work exactly the same with no difference. I think I could even program the listener to pass in the instance of the node rather than the tile ID, which would work just as well. But we'll use a Tether for this case because then you can sit here and you can look at this Tether, and if you guys are making mods for 1.7, you can copy and paste this. And I think Tethers still exist even in the newer versions of Minecraft because I never got rid of them because Minecraft didn't even get rid of them. Minecraft actually still uses Tethers for most of its tiles. It's tried to move as much as it could to a JSON-based system, but the reality of it is JSON has its limits. If you want to do more complicated things with JSON, you have to physically go in and tell the processor that pulls the JSON file in how to behave when it looks at that data. So if I want to render say this, if I want to do some logic here, I have to go, okay, if I'll make a new state, and my new state would render this cube as addition to my previous state, and I would have to go check for like a has fuel state or a has cooking state, and I have to do that. So you can do this with the JSON system. It's just I would have to go in and program it. I probably will go do that. I want all of my render code to be JSON based, even though I know my Mojang won't do the same with their stuff. I don't really care what they're doing though, because the reason I do JSON is I'm trying to avoid as much work as possible when it comes to updating. So right now I'm still in the process of beating code into submission. I just realized I'm running the wrong setup here. So you probably noticed, you can see all my tabs, everything in the song was in the wrong spot and everything. I was running my Nomeria stream software. So it's now flipped over, but yeah. So I'm in the process of still working on transitioning my code from 1.7 to 1.12. It's a really big jump. And the ideal of using JSON is to eliminate huge amounts of work, so I don't have to do tons and tons of work updating. So you only have to update one object, and that one object describes how everything works for that type. So if I have a gun, I have one gun object, and that then loads like thousands of guns I have made. I have one sentry object that then works with all of my sentries. I have one block, and that runs all of the behavioral logic for all of my blocks. And one spot updating is better than what most mods do. Most mods actually end up having 30 or 40 different blocks in them. You look at IC2. IC2 has, I think, 2 main blocks and then a couple variations on those. And then they have like 30 tiles, tons of prefabs, and they're all attached to Minecraft. So every time it updates, they have to go through and literally rewrite up to 30% of their mod. And in the case of probably the transition from 1.7 to 1.8, they probably had to rewrite half of it in order for it to work. There's a lot of reasons why mod developers also skipped the 1.8 transition, because it was rougher. The 1.7 to 1.9 was easier, and if you just skip from 1.7 to 1.12, it's even easier than that. It's they actually started making the code a little bit more flexible with each iteration. But the 1.8 transition, oh man, it was. I wish they just kind of would have waited until they made the 1.9 version, called the 1.9 version 1.8, and things would have been so much smoother. But they had to cut their teeth on something though. You can't just make a JSON system and be like, yeah, I'm done with it, because even I've went through hundreds and hundreds of iterations on my JSON system, and it's not perfect. It's not even done either. There's so much code that still has to be done with it. Like, I still need to have handling for certain types of recipes. I need to have handling for for loops in my recipes. My recipes don't support for loops, but a for loop would be really nice to have, because some of your recipes are only one item variation of each other. Like, say for example, I want to support like all these different microchips in my recipes, but they all have different OR dictionary names. A for each loop would be a perfect solution for that. And I actually did, in a previous episode here, we made a for each loop that all I have to do is go implement it now. Although that's going to be... No, it actually wouldn't be too hard to run. That'd actually probably be pretty easy to implement, now that I've got all the for loop stuff actually prefabbed out properly. So the only thing the for loops do now is they just generate code. Yay, we got fire. So yeah, that's too big. So what we want to do is we want to scale that down. And speaking of which, where's our piece of cube? Hold on. We need to take a look at how our cube's working. Render cube, render cube, render cube. Okay, GL push. So it already does a push and pop matrix. I don't need those. Render manager. Set render bounds. Okay, so we made a mistake on how we designed this. One, we don't need to be pushing and popping matrix. It's already done for us. 2, we need to make sure we actually add our translation here. So it looks like it does depend on understanding where your render location is. And I'm going to just have faith that I'm being passed in the actual render location of my tile and not the theoretical render location of my tile. I've had this happen. Entities, it's particularly a bad problem when you'll be passed in an estimation up here where it's not the perfect location of your render. Still not seeing my cube being rendered. I'm not getting any errors either, which is concerning. I'm having some multi-block problems, but that's just because of stupidity reasons. Oh, I know what's going on. 1.2, 1.4. No, that's not it either. I keep placing the blocks and it's just going to re-render. It's not. We're gonna invert all this. I'm gonna go back to this. That is like 0.6 off the ground, so I'm overestimating where my Y position is. 0.6. Yep, there we go. There's our little black cube. We're not centered though. Then again, we didn't program ours to be centered, did we? Okay, so it's rendering right on the edge here. So it's rendering, that's probably the corner. And we can see that the flame is right above it too. I think we need to do minus on this. Nope, that just flipped us to the other corner? Wah. You have one of those moments where like something just doesn't make any sense at all. Oh, I know what we're doing wrong. Okay, so blocks are designed to render on corners to start with. So if you move something, it's going to render on the corners. That works. And that looks interesting. I'm going to actually take a picture of that because that's an undesirable effect but still looks pretty cool. We want our cube to be bigger. So our walls are like 0.2 thickness. So what we can do is we can say that's 0.2. This goes to 8. That goes to 8. This is 0.2. There we go. We got some cool in there. I'm going to drop its height down though because it's a little too tall. There we go. We got some coal in there. And what we can do is we can put some wood flakes in there as well so it looks like you've actually shoved some wood into it. All honestly, what I want to do is put another opening at the bottom here and then put the coal in there and then you put your actual item in here. But the client said he doesn't want a lower opening on it, so we'll go ahead and do this and then I'll ask him if he really wants to change his mind. So our flame is too high off the ground for starters, which is understandable because I set the height too tall. There we go. And then now we want to, after translating, we want to scale it. I think. Yes. Yeah, it sounds about right. And we want to scale it down by half. Look at our little baby fire back there. We actually don't want to scale it by that much. That's so cute though. We may smash the height of the fire too. Cool little tricks you can do here. I need to translate the location of this. And you know what? We're going to scale and then we're going to translate. Yeah, no matter what we do, we're going to have to move this just because we've scaled it down. And we just need to be like negative 0.2 in each of the corners, I think, is what we need to do. I think actually this needs to be plus 2 because when we did plus, we went to the other corner. When we did minus, we went to the back corner. There we go. That looks pretty good. And then what we're going to do is we're going to smash it in the Y level. Dude, that is perfect. That is, oh. This is why I program. When you get beautiful things like this that don't make sense. So like you look at this, you look at the code, and this, you look at this and it's like, this, what's this code do? We're rendering a cube and we're rendering fire. The code by itself doesn't lead you to believe that something beautiful is being made. And then when you come over here, you end up with something beautiful. It's just that kind of magic of being able to write words into a text file and then hit compile and they turn into something that actually looks amazing. Now the only thing we really got to do is we got to just make maybe an item render in there. So if like we're smelting an ingot, we want an ingot to show up in there. And then we want some smoke to come out of the top, and it's done. I mean, I'm definitely not making enough money for this, but ooh, it's so nice. I need to scale it down a little bit because I'm watching it poke fire out of the corners. Actually, we want this to be 2.5 because we're changing it by half a degree, which means we need to move it back by half. There we go. Ah, it doesn't look as cool. It looked a little bit more beautiful with having a little bit of fire coming out the front, but now we actually still end up with different results on each side. That's that tells me it's not centered. So let's actually do 0.2, 0.2. I think I threw the center off even more. So if we scale down by 0.65, that means we have 35. That's all my icons are broken on my computer. Yeah, so 35 divided by 2, 17.5. So we're going to try that and see if that gives us a proper center point. No. No. I think what we need to do is we need to actually just push it by 0.35 in all directions. This is also the frustrating part about working on software development, though, is that centering something can get tricky. So what it looks like is the Z direction is not being pushed correctly. Or it's being pushed too far. And let me go and see, it needs to be brought back a little bit. So maybe 2.5 is the correct direction? Doesn't make any sense. So we sit there and we're messing with it. So you get that pulls it back, and now we're too far on the other direction. So now we need to bring it back another 0.5. You know, that looks okay. Looks okay. I mean, it's popping a little bit on some of these sides. So I'm gonna say these actually are 0.26. Because we want the results, even if they look better in certain sides than others, we do want the results to be consistent. Because you don't want to end up with a situation where like something looks different in one direction versus the other. Maybe what we want to do is we want to just take this to 0.6, and then we can do 3. We make it smaller, but it might render better. That's more consistent results. Yeah, it looks nice. I mean, we do have a little bit, you can see where if you watch the side, there's some flickering coming out there. That's okay. That's not too big of a deal. But I'm gonna call that it. So that's a good run there. So I'll do the smoke here later in another video because I gotta go pay attention to what my dog is doing. You can probably hear her bark across the house, and it's a good stopping point.